Okay, here we are back with our data that we put into this nice table here. I think I was calling it a chart. I should have been calling it a table. One thing I did notice though when viewing the last video was the number of sig figs shown here is not correct. Really, we should be to 1/100th of a gram on all of these, but if you put a 0 as the 100ths placeholder, the computer sees it as an unnecessary 0 and just automatically gets rid of it. So the way to fix that, to show the correct number of significant digits, is to go into data, go into format, and click 2 decimals. That way it forces it to have the correct number of decimal places. Okay, and we'll do the same thing over here. Perfect. Okay, so now we're good to go. All right, so what we want to do is we want to insert a chart. You can do that in one of 2 ways. You can either click this button right here, insert chart, or you can go insert and click chart. Either way does the same thing. So the first thing that you want to do is you want to select what data we're going to put into this chart. So I'm going to click select data range, and I can move this around, and this is going to be my x-axis. Okay, and I'm going to add another range because the actual measured mass is going to be on my y-axis. So independent variable, dependent variable. All right, you can go in if you do this backwards, you can go in and switch these around. It's just easier to do it right the first time. The first one will be your x-axis. What you choose next will be your y-axis, and you'll see that we can plot more than one set of data on the y-axis. Okay, so I'm going to hit OK. It's going to take us to this thing here. It's going to show the data we selected, which is perfect. But it's not going to show the kind of chart we want. We don't want a combo chart. We don't want that. What we want is actually just a line chart. Okay, X versus Y. Now the way it comes up, what it's doing is it's recognizing the 2 columns I selected as being independent data types, which we don't want. So we're going to click back to start, and we're going to go use column A as labels, right? So what it's saying is column A is now labeling each of these things. So our labels are 1 penny, 10 pennies, 25 pennies, and 50 pennies, okay? And we want to use row 2 right here as the headers. So what that's going to do is say measured mass plus or minus 0.05 grams. Okay, now we're going to customize the chart to make it look like we want it to. So the title of the chart is mass versus number of pennies. Okay, remember you're always plotting your y versus your x. Okay, legend is fine. Move down. Background's fine. You can change color if you really want, but it's definitely not necessary. Okay, slide down. Okay, we have some stuff that we can do with actually, I'm not even really sure what all of these do, but you can play around with that and see what it does if necessary. Okay, now we're going to do some formatting of our horizontal axis or our x-axis. So we want a title, and that is, so I gotta click in there, number of pennies. Okay, we can change the bound area. So in other words, it doesn't really need to go up to 60. Let's change that to 55. Okay, not much changes unless we do this. And there we go. Okay, so now shows a maximum of 55. Now that's just up to you to fiddle around with and get your chart looking like you want it to. We're good there. Now I want some more grid lines on here. I'll leave the majors at 5. We'll put in some minor grid lines. Okay, notice these are the horizontal grid lines. It just should line up better. Okay, now I'm going to go back up here, switch to my y-axis, and change the name, and this is mass. It's measured in grams. Okay, I think it's okay how it looks right now. Do the same thing with the grid lines, put some minor grid lines in. Okay, and of course you don't want them to be white because you'll never see them. Nope, I don't like how that looks. Those dark, those light, and that's a bit dark. There that looks okay. Switch back here. To my horizontal. I'm just gonna do the same thing with the grid lines here so they appear a little bit more clearly. Okay, yeah, that's a pretty good looking chart right now. Now the line itself, I don't really particularly like right now. I think it's too thick, so I'm going to drop its thickness down. And I do want to see the points, the data points that I actually picked. So there they are. And the other thing that I have to add now are error bars, okay? So these had constant error of 0.05. Okay, now they're going to be extremely small error bars, right? Right now it's showing 10. You'll see right away when I do that, they just shrink down to these. Okay, what that's showing, if I could zoom in, is that there's an extremely small amount of uncertainty associated with these measurements. Okay, all right, so that's pretty good right now, but I also want to put my other data on here as well. Okay, so I'm going to go back to start. I'm going to select another range, okay, and I'm going to add another range of data. This is going to be our predicted masses. Okay, so we didn't do one, so we'll do that right there. Oh, I'm sorry. Actually, what we'll do is we'll do the whole column. So it'll have a header on it, and there it is. Okay, our predicted mass instantly appears as a second range of data, and it measures, again, 10, 25, and 50. Okay. So let's go back to customize, and let's mess around with that second line that we just put in. So down to lines, we want the predicted mass line, do the same thing, 1 point. We want the 2 point point size, or the 2 pixel point size, and this now has a percentage of error associated with it, and it was constant, I'm sorry, it was percentage. It wasn't 10%, it was 2.07. Okay, all right, so what that does is it pops in 2.07% error on each one of these values. Okay, we're going to insert this chart right in there. So there's our data table, and there's our chart. Something that you can do, that I like to do, just to see it better, is I can put move to own sheet, and then what you'll have is a nice big chart that you can check the data on. Now, just a couple things to notice with this. Okay, we can see here that our predicted masses were always below the value that we wanted. Now, just notice this is not doing what I want, so I'm gonna actually have to go back in and fix that. And I'm not sure why it did that. Let's just see here. Not sure why it's doing that, but anyway, I'll figure that out and just explain why this is incorrect up here. This should actually say measured mass of pennies. Okay, well anyway, you get the picture, and we'll just fix that later. But what you should notice here, if we go back into our chart, is that even with the error bars, even with our propagated error, we can see that the measured mass is outside the allowable range of uncertainty based on our original measurement. There's probably a really good reason for that, and it's very likely that the original penny measured down here was a penny of below average mass, and it turns out that depending when the penny was made and where it was made, because there's probably some American pennies in there, pennies do have a bit of a range in how much they actually weigh, so they're not perfectly uniform. All right, so that is a major flaw in this lab, and if you were to write a lab up with this data on it, you would have to explain why your data is outside the allowable error. And remember, the allowable error or uncertainty on here is extremely, extremely small. We're using very accurate scales to weigh these pennies. Okay, so this is a systematic flaw, and the reason for it, of course, is a non-representative penny was originally used to propagate or to predict these values. Okay, so I'm sure you can think of a much better way to represent the value of a penny, and that would be to measure multiple pennies, find an average, and propagate forward from that. All right, thanks for watching, and we're done graphing.